Okay, so let's look at prime implicants. Now, it's really important to have these terms straight because I think it clarifies what we do with them. Now, the word implicants, that term is referring to the adjacency of terms. So if we have 0, 0, 1, 0 and 0, 0, 0, 0, if we want to get from term 1 to term 2, we just change one digit. That means it's adjacent. What would not be adjacent, for example, would be this example where you have to change a 0 to a 1 and another 0 to a 1. That's two changes, not adjacent. Now, for me, it's tricky when we have something crossed. So if we have this type of shape, this crisscross, right? My instinct, my visual instinct might tell me that these are related by some sort of math. But in terms of adjacency, they are still two apart because you have to change the 0 to a 1 and the 1 to a 0. So they're not adjacent for our purposes here. Now the prime part of this name, Quine, from Quine-McCluskey tabulation, he defines a prime implicant to be an implicant that is minimal. So basically, we're looking for the smallest way to express adjacent terms. So smallest adjacent terms. Right? But we can't call it by simple words. Or you can even say smallest neighbor terms is even more kind of easy to think about it. But we're in college and academia. You can't have simple things. So we have this fancy name for it. Okay, fine, sure. Now, the rule for them is to group them by powers of 2, and you particularly look for the largest powers of 2. Well, let's look at the reasoning for why that is. It's kind of, it seems arbitrary at first. But let's put the ones, let's say these are all true. Now, if they were true, we would say, okay, 3 is true. We would say 11 is true, 7 and 15, and we would say the rest are false, right? I'm not going to fill it out. So let's look at what those binaries look like. You have the 11 and the 15. Okay, so those are our 4 terms. Now, of note is, okay, look, it's all a column of 1s and all a column of 1s. Now, those columns are basically saying z and t, because it's 1, are guaranteed to be true if you can cover all the permutations in the other terms. And let's check if that's true. Well, 0, 0, 0, 1, 1, 0, 1, 1. Okay, that's true. So we can say, okay, this term is just zt. And this has to do with why it's powers of 2. Is the amount of permutations gets multiplied according to the size. Let's look at a case. Well, let's say, what if we just circled, what if we just had 3 of them? Why wouldn't that work? Let's say we took out the 15. So, okay, I'm in green, I guess. So now we're 0, 1, 1, 1, and 11 is here. Okay. So now we have, we have the 1s. We have the other ones here. But then here we don't have all the permutations. So we can't really say zt because it's messy. We would actually have to circle 2 and 2. Yeah, and what would that look like? That would look like 3 and 7, and we would have 3 and 11. Now, do these work? Well, now they have each 3 in common, and because they have 3 in common, they cover all the permutations for the remainder, so that's okay. Yeah, and this would get simplified. Well, let's see, not x, third term, yes, z, t, and if you look at the map, let's see if that pans out. So not x, good, right? Not x, z, yep, and t, yep. And let's look at this one. Well, we have the 0, so that's not y. Yes for the t, and the z. And so let's look if that lines up. Not y, yes, z, yep, and t. So that's why with when we only have 3, we can't group it as 3. We can't do non-powers of 2. Well, let's look at an example where we have a power of 2, but it's still not the right thing. Well, let's get a clean copy here. So let's say we have, let's go to white. White is a little nicer. Let's do this shape. Yeah, so we have this kind of tetra shape. Why would that not work? Well, let's go over the numbers. You have 0, you have 1, you have 5, and you have 3. I did it out of order, but it should be evident enough either way. Okay, so we only have one, the first column, the zeros are in common. But then for the rest of the terms, not only do we have mismatching terms, but we don't have enough permutations to cover all of these, all the possibilities of what not x would be like. Because not x, if it were really just not x, it would have to cover all of this realm, right? And it doesn't. You're missing 4 terms, 4 possibilities. So that's why you can't just have that L, not L shape, tetra shape. Well, let's look at an L shape. Talking about L. So what do I mean by L shape? This, well, that's backwards L. This shape. I know my letters. Okay, so that's 2. That's 10. This is 11. And finally 15. And yeah, only the ones match. And for 3 digits, we don't have enough permutations to cover all the possibilities. So that rules out this type of shape for implicant. So we can't circle it that way. We would have to do 2 and 2 and 2, 2 and 2. Now this whole logic also ties in as to why we can cross over to the other sides. And this one. Well, let's look at that corner case where you have all ones in the corner. The strangest one of them all. Well, you have zeros, and you have the 4, and you have an 8, and you have a 12. 12 is this. Well, you have the 2 0 columns that are correct. So we can, and you have the permutation 0, 1, 1, 1. So that works out. So this would be represented as not z, not t, or z prime, t prime. Is that correct? Well, we look. Not z, z prime, t prime. Z prime, t prime, yep. Z prime, t prime, yep. Right? And z prime, t prime, yep. So that works out. Now, let's see. So, you might have noticed if you have, so those size 4 implicants, they give you just 2 literals. You can express them with 2 literals, right? We did like z prime, t prime. What's that last example? I forget what the others were. Well, what if it's size 2? Or what if it's size 1? Well, if it's just size 1, you look at x prime, t prime, z prime, y. So you use all 4 literals. So if it's size 1, you express it with 4 literals. That example was x prime, y, t prime, z prime, out of order, but you get the idea of this one over here, right? Well, now let's expand it. Let's say it's size 2, size 1, size 2 will be what? Well, it's x prime. The t's cross over, so they cancel out, and you have a z prime, and y. So 3 literals. X prime, z prime, y. Out of order, but works for now. But I hope you see the pattern that's happening. This is 4, this is 3. When we have a size 4 literal, we saw before that it was going to be size 4 implicant, sorry. 2 literals, right? Like not z, not t, was the corner case. That case. And then if you have a size 8, well, let's look at that. Size 8 is this whole chunk. That's x prime for sure. Vertically crosses over, so you cancel these out. And it crosses over with the z's. So that's just x prime. So size 8 implicant is just 1 literal. Yeah. And by the same logic that we did before, it should work out. You could test it yourself. Anyway, that's a very quick overview of the fundamentals. I'll try to cover other things later.